Hello, very good morning to everybody. Let's return back from where we stopped previously. So previously we have finished discuss the objective questions for chapter 5. So we are going to continue with the structure question for chapter 5, which is about hydroxyl compound. So let's together have a look at the questions. Structure questions, question number 1 starts like this. Cyclohexanol and phenols are both solid with low melting point and they are fairly soluble. So compare and explain the acidity between cyclohexanol and also phenol. So in here, you have to know on what are the reasons that makes cyclohexanol and phenol, which ones is more acidic. So in here, it is obviously that phenol is more acidic compared to cyclohexanol. So the points that you have to make in order to explain why is it that the phenol is a stronger acid than cyclohexanol is because either you mention it as the benzene is an electron withdrawing group, or you say cause inductive effect as electrons are delocalized in the benzene ring, hence stabilize the phenoxide ions. So these are the reasons why phenol is a stronger acid compared to cyclohexanol. So you must be able to make all these points in here. So what happens as a result? So as a result, equilibrium favors to the phenoxide ion, or you say cause the OH minus bonds dissociate easier. So that is why phenol is a stronger acid. Now, teacher, can I explain from the angle of cyclohexanol? Of course you can. So from the angle of cyclohexanol, you have to explain in such a way that says that cyclohexane in the cyclohexanol is an electron donating group. So as electrons donate to the OH group, it makes the OH bond become stronger, hence harder to dissociate. So either ways that you use to explain why is it that a phenol is a stronger acid or cyclohexanol is a weaker acid, both are accepted. So immediately let's have a look at question number 2. For each of the following reagent, draw the structural formula of the organic product obtained from each of the two compounds. If no reaction occur, write no reactions in the box. So we start off with sodium. So since sodium is a metal, well, both phenol and cyclohexanol are acidic, so both can react with metal. So phenol will form sodium phenoxide, cyclohexanol will form cyclohexane oxide. So both of them will react with sodium. Number 2, S for sodium hydroxide. So which one will react, which one will not? So it seems that phenol can react with the phenol can react with sodium hydroxide, while cyclohexanol shows no reactions towards the sodium hydroxide. Third one is bromine water. So bromine water is a chemical test used to distinguish between phenol and cyclohexanol, where phenols, when dissolved in bromine water, first decolorize the bromine water and hence give a white precipitate of 2,4,6-tribromophenol, while cyclohexanol give no reactions of the bromine water. As for the next one, we have iodine in sodium hydroxide. Now, this is rather tricky questions because iodine in sodium hydroxide, which is also known as the iodoform test, is used to test the presence of methyl alcohol. However, both phenol and cyclohexanol do not have methyl alcohol. The trick part in here is that you have iodine and hydroxide ions inside here. So you might want to be extra careful with the hydroxide ions that is formed inside the that can react with the phenol. So in here, the phenol in here can react with the hydroxide ion, while no reactions is shown by cyclohexanol. Last but not least is an excess of heated acidified dichromate ions. So this is an oxidizing agent. So obviously phenol cannot undergo oxidation, but cyclohexanol, because it is a secondary alcohol, it can be used to oxidize the to become ketone. So you have cyclohexanol form at the end of the reactions in here. Okay, so this is for number 1. Then we continue to question number 2. Phenol can be synthesized from benzene by the route shown below. You have benzene, then you react with concentrated nitric acid and concentrated sulfuric acid. Then nitrobenzene, react with reagent A, you form aniline, react with sodium nitrite and hydrochloric acid at 0 to 5 degrees Celsius, form X, and then react with reagent B to form phenol. A, draw the structure of the intermediate X in the box above, 1 mark. and suggest the reagent condition for A and B. So for structure of X, this is actually a benzene diazonium chloride ion. Okay, so you must draw out the benzene diazonium structure. Positive, negative must be stressed because some of the students might not be able to know where are the exact location of the positive charge. Always remember, nitrogen have 4 covalent bond, usually carries a positive charge with it. So students must very well understand where should the positive charge belongs to. So you cannot ignore this positive charge because it is important, especially in the labeling of the benzene diazonium chloride compound. B, suggest the reagent condition. So A is, what is it? A, yes, as you already know, it is hydrochloric acid in tin, SN in HCl. As for B, it is water under reflux. C, state the type of reaction when A, benzene is converted to nitrobenzene in the steps 1 here. So as you can see, this is the type of electrophilic aromatic substitution reactions. So therefore, the answer is pretty straightforward. Whereas nitrobenzene become aniline is actually a reduction reactions. So you must know by yourself that these are the processes or these are the type of reaction take place when these reagents and conditions are applied. Then we go to D. Phenol can be used to synthesize compound Z according to the following equation. So you have phenol react with C to form an ester. If you look carefully, looking at the functioning group that is present in here. So this is an ester group in here, isn't it? So, however, because we are forming ester by using phenol, so the compound of the Z is extra careful. So you must be able to understand what do you use to form C first before you name the compound Z. So Z is called as the phenylbenzoate. State the reagent condition required to convert phenol to compound Z. So what is added to C? Now this is a very specific conditions that you must be able to give in order to form ester with phenol. So for the case of the carboxylic acid derivative, you must specifically only use acyl chloride. So depending on the number of carbons in here, as you can see inside this ester, there are 2 carbons in here. So when you have 2 carbons in here, so you should use something with ethanoic acid or derivative. Since you are using phenol, you must only use acyl chloride. So Z must be CH3COCl under reflux in alkaline condition. I forgot to add this. So you might also want to add in alkaline conditions. In NaOH, you might add. So what is the function of the NaOH? It is to use to form the phenoxide ions. So these are some things that you have to know. Okay, so with that, that is for question number 2. Immediately we move to question number 3. Ethane 1,2-diol is one of the widely applied alcohol in automotive and polymer industry. It can be prepared from ethanol via the following reaction scheme. So ethanol react with E to form compound P, and then you react with substance F to form ethane 1,2-diol. So state the reagent condition E and F required to convert ethanol to ethane 1,2-diol. Now it might seem pretty easy because some of the students thought that, oh, just simply add 1 OH. So how are you going to add the OH conditions in here? So diol can usually form by reacting from alkene. Okay, so these are the points that you have to come up by your own. How does you form a diol easily? Usually a diol is formed when you react with alkene. So you react under cold alkaline potassium manganate in order to easily form diol. So that is why for alcohol, for the ethanol in here, we have to first convert to become alkene. Then alkene, you react with the reagent that I have mentioned just now, cold alkaline potassium manganate, so that you form the ethane 1,2-diol. So for compound E, E is excess concentrated sulfuric acid under reflux, whereas F here is cold dilute KMnO4 in alkaline condition. Okay, as for compound P is here, it is the ethene. C, using suitable reagent and conditions, state the observation and write equation that can be used to distinguish ethane 1,2-diol and ethanol. One of the general key that you can understand in here, how do you distinguish between ethanol and also ethane 1,2-diol, is the presence of what we so-call as the methyl alcohol group. Okay, methyl alcohol group. So ethanol have that. So every time when you want to state a chemical test, we usually recommend students to write 3 very important things, starting from the reagent conditions, followed by observation, and finally equations. Okay, so in here you can use alkaline iodine solution under reflux if you might want to add. So here I also state that it's under reflux, shall we? Okay, then in here, ethane 1,2-ethanol will give yellow precipitate, while ethane 1,2-diol shows no observable changes. Now, these are the key that you have to be extra careful. You must say is that no observable changes or no visible changes. Cannot use the term no observations. Okay, no observations means you can't see a thing. And finally is the equation. So you put the equations between the ethanol and also alkaline solution. Okay, so you form the following compound as I mentioned in here. How about the side product? Such as, for example, water, hydrogen iodide, those are not very important, especially in the organic chemistry chapter, so you can just ignore them. The most important thing is writing the salt and also the iodoform that is formed from these reactions. So that is for 3A, B, C, and finally 3D, state and use ethane 1,2-diol apply in each industry mentioned below, so automotive industry. So you must memorize this on your own, as ethane 1,2-diol is used as an anti-knock or anti-freeze in the car engines. Whereas polymer industry, it is used as the monomer of the terylene. Okay, so these are very, very common applications of ethane 1,2-diol. Hopefully you'll be able to remember this. Finishing number 3, let's go to number 4. Menthol is the main constituent of peppermint oil. So menthol is made commercially by reducing piperitone, which occur from the eucalyptus oils. A, state the IUPAC name for menthol. So if you look carefully, if this is the functioning group, this will be carbon number 1, this will be carbon number 2, and this will be number 3, 4, and number 5. Okay, so and then you have to identify what is the alkyl in here. So this is methyl. Okay, and this is isopropyl if you look carefully. Okay, so according to the IUPAC name, you have to name put the substituent according to the IUPAC order. So the full name for menthol is also known as 2-isopropyl 5-methyl cyclohexanol. I forgot to add the word cyclo there. Can you help me to add cyclohexanol? Okay, cyclohexanol. Okay, so that is to A, and B, set a suitable reagent and condition, convert piperitone to menthol. As you can see, obviously, the difference between the piperitones and menthols are, in piperitones, you have a double bonds in here, and also you have a ketone in here. So how do you convert to become menthol? By only using a single steps process. So this is obviously to change unsaturated hydrocarbon to become saturated hydrocarbon, you must use hydrogen in nickel only. And for your information, hydrogen and nickel can also be used as a reducing agent to reduce ketone to become secondary alcohol. Therefore, the best and suitable reagent condition to convert piperitone to become menthol is by hydrogen in nickel under reflux or under heating also can. Okay, so that is how you convert piperitone to become menthol. C, draw the structure of the product formed when menthol react with the following substance, phosphorus pentachloride. So the OH group in here will be substituted with the chlorine in here. Okay. Okay, so you can see that it becomes Cl, and then hot concentrated acidified potassium manganate in here, you form back the ketone. Okay. However, unlike piperitone, here you have no more reactions with the hot acidified potassium manganate. Okay. And last but not least, D, state a chemical test to distinguish piperitone and menthol. So in here, because it is a ketone, you can use any chemical test for ketone. For example, 2,4-dinitrophenylhydrazine, or you can even use bromine in CCl4. So because in the piperitone, you have a C double bond C in there, isn't it? Okay, so piperitone shows orange color or decolorize the brown color of bromine water if you use that, while menthol shows no observable changes in here. So these are the equations for the reactions. If you were to use bromine in CCl4, or if you later you were to use 2,4-dinitrophenylhydrazine. So you must be able to give out the correct structure when you use the suitable chemical test in here. Okay, so with that, that is for question number 4. Then we go to question number 5. Structural formula of an organic compound is as follows. So you have a phenol, you have this alkyl alcohol also. So draw the structural formula of the organic product or products formed when react with each of the following reagent. So number 1, we start with sodium metal. So as I already mentioned in question number 1, the sodium metal can react with both phenol and alkyl alcohol group. So the product that is expected in here is form ONA and ONA. So teacher, can I not write the Na in here? Cannot, because the questions already give sodium metal. So in your answer, you must also strictly have sodium inside your answer. Number 2, aqueous solution of sodium hydroxide. So only phenol can react with sodium hydroxide. So you form ONA and CH2CHOHCH3. Okay, number 3, alkaline iodine solution. As you can see clearly, this is where the methyl alcohols are situated. So once you have the methyl alcohol group inside the organic compounds, so you can easily know that, okay, so this is the golden triangle. So this is the part that will react with alkaline iodine solution. Okay, so eventually, don't forget, because it's alkaline, okay, because it's alkaline, the behind here, the OH behind here, okay, will also react with the sodium hydroxide, okay. Number 4, hot acidified potassium manganate. So no matter how long your hydrocarbon is, so at the end of the day, you form caustic acid in here. So this is claimed as the major product of the reactions, yeah. Okay, number 5, the structural formula of an organic compound is shown below. So draw the structural formula when react with bromine water. So as for the bromine water, it can react from the phenol direction. However, phenol in this case already occupied the 5th place of the phenol inside the benzene ring. So the bromine can only attack at the position number 2, which is the auto position only. So you're expected to have this compound. Okay, number 6, thionium chloride. So still remember that if you want to convert OH to become Cl, so you have to use a chlorinating agent. So what are the example of chlorinating agent? Either you use PCl5 or SOCl2. Okay, so in here we use SOCl2, thionium chloride, so that you form secondary alkane. So please bear in mind, thionium chloride cannot react with phenol. Okay. And last but not least, ethanoic acid catalyzed by concentrated sulfuric acid under reflux. So this is actually used to test the chemical presence of this one. You form ester from the angle in here. Okay, so your expected answer is supposed to be like this. Okay, so with that, that is all for the questions number 5. Last but not least, we go to question number 6. The acid ClCH2COOH features in small industrial synthesis of the important weak killer 2,4-D. So you have phenol number 1, and then you have you form ClCl at auto and para position, then you form NaOH to form ClCH2COOH, and finally you form 2,4-dinitrophenylhydrazine. Sorry, the compound 2 killer weight 2,4-D. So number 2, compare, explain the acidity of A and phenol. So what is the differences? Because phenol, you only have a hotel. Sorry, you only have this phenol, okay? But A in here, you have Cl. So the Cl, which is electron withdrawing group, will increase the acidity of the phenol. So acidity of A is greater than that of phenol because chlorine causes inductive effect, or you said that electron withdrawing group, so increase the acidity. Number B, what is the type of reaction? Number 1 is electrophilic aromatic substitution reaction. And number 2, as you can see in here, it is a neutralization reactions. Then we see number 7, number C, describe a chemical test used to distinguish phenol from compound X. So X is the phenol, and then Y is methyl, this phenyl methanol. So in here, unlike phenol, where it is directly attached to the OH, so it cannot react with any specific compound. So in here, we will specifically recommend if you use bromine water, also can, okay? So the phenol decolorize the brown color of the bromine water according to the equations in here. So there I have for you all the answers for the objective structure, sorry. So hopefully you all will be able to understand. So I see you in our next video lessons, okay? So that's goodbye for now. Thank you very much. See ya.